After you have taken down information about a potential problem on the network, what do you do with it? Fortunately, many automated trouble ticket systems have evolved to handle such reports. A trouble ticket is a record describing a problem or event on the network. A trouble ticket might describe a failure of a modem maintained by the network, a site's electrical problem that makes its internal network unusable, a failure of a network news transmission, or any of hundreds of things that can go wrong. As an employee of a NOC, each time you receive a report on a problem, you should check if a trouble ticket for that problem has been opened. If not, open a new ticket immediately. D. Johnson of the Merit Network compares a trouble ticket to a hospital chart, so this is the equivalent of starting a new chart for a hospital patient. As each patient is given an individual chart, each problem on the network is given its own trouble ticket. A trouble ticket, like a hospital chart, allows all details about a problem to be noted in the order they occur. This information will include the date and time, the source of the report, for example, whether it was from the hotline, email, or another source, your name, and the site reporting the problem. A trouble ticket is also a piece of correspondence between the NOC and the engineering staff, with a description of the problem and a record of steps taken to try to solve it. Any worker who arrives to help with a network problem must read the trouble ticket to find out what has been done to address the problem. A trouble ticket is only closed once the problem has been fixed and the solution has been added to the report. The order in which a trouble ticket is handled is based on the level of importance, which includes the network territory or jurisdiction, its priority, and the deadline of the problem. Every NOC is responsible for a particular network territory or jurisdiction. Your NOC may be responsible for an entire regional network, a state network, a large multi-location organization on a network, or a particular site with any number of network hosts. It is important for you to know the jurisdiction of your network and to know which sub-branches of your network have NOCs and which do not. Some problems include, whose problem is it? Your NOC's or another site's NOC. You may need to contact the other site and let them know they have a problem. If computers on your network are unable to reach the larger network and no changes have been made to your local computers, contact the larger network. If a piece of equipment within your network is down, or you're unsure of a problem, especially if it will affect the entire network, be sure to contact the engineer. It is the phone carrier's responsibility to fix any problems with the telephone lines, and a local computer center is usually responsible for fixing any problems with the site's internal local network. Your network's connection to the outside world is generally the highest priority.
Oh man, I can't get onto my astrology page.
The availability of a site on the network or a particular service that is not working for one site is generally the lowest priority. As an employee of the NOC, your duties will include maintaining records of events and problems, giving information to users and network engineers, and monitoring and diagnosing problems on the network. A trouble ticket system is used for logging problems or events, correspondence between NOC staff members, and closing problems once they are fixed. Remember, trouble tickets must be prioritized. You should know the steps required to open, update, and close a trouble ticket. You will need to contact a network engineer when network equipment is down, a problem will affect the entire network, or you can't locate the source of a problem. Computer scientists have often used the image of the cloud to explain the network. The network is basically invisible to the user. However, as a NOC operator, you must blow away the cloud and know the physical layer underneath. Any network is made up of sites. A site is usually a geographical place that contains several computers on a local area network, or LAN. To different people, a site is defined differently. From the perspective of a NOC that operates a large organization's network, for example, each department's local area network is considered a network site. From the perspective of a NOC that operates the regional area network to which the organization is connected, the entire organization is a site. From the perspective of a national network, the regional network is a site. But when a user of electronic mail at a college or university campus works on a personal computer, then the user's computer is called a node on the network. The larger network is made up of cables among the geographically closed computers or nodes, such as in a company's training facility, and data telephone lines leased from a commercial phone carrier. The telephone lines are commonly referred to as leased lines. A leased line can transmit at one of three possible speeds. 56 kb or 56 kilobit lines transmit at 56,000 bits per second. They often serve a small site or are a starting point for a large company that is considering leasing a higher speed line in coming years. T1 lines transmit at 1.5 million bits per second. They serve large companies or universities. Many state and regional networks use several T1 lines to carry shared traffic between different parts of the network. T3 lines transmit at 45 million bits per second. They are very expensive and are used for very long-distance national networks. The network's engineering and management staff plans the placement and use of the leased telephone lines. The backbone runs between special network sites called hubs, which are run by the central network. At the hubs, many leased lines branch off to reach individual network sites. In the past few years, organizations have begun using a regular voice phone line or an ISDN phone line to dial up the network and transfer data periodically. Only a computer, a modem, and some sort of TCP/IP software are required. This option, called dial-up internet access, is less costly and easier to implement than leasing a permanent data line from a telephone carrier. Some network operation centers support dial-up users by resetting modems and enabling functions through special computer commands. To demonstrate the equipment needed at a network site, let's follow a data packet from a computer out onto the network. First, the data will leave a computer on a site's local area network and travel to a special computer called a router, which has been designated as the point of passage out onto the Internet. A router is specifically designed to route or direct traffic. The data enters a special piece of equipment that enables data transmission over a phone line called a CSU/DSU. The data passes onto the leased phone line where it is received by another CSU/DSU at the regional network's hub, where each site's outgoing network traffic passes through another router. At least one of the leased lines connected to a hub router will be part of the network backbone, where the data will eventually reach another hub and another router. The subsequent router may direct the data to another leased line leading to a site, or to a gateway onto the national network,